All right, we have the disc brake over here. We're trying to find features for why CAD can be good or how CAD can assist engineers. We're going to start, we want to find center of mass and we can adjust that value. I want to have a little bit of a cone coming out here on this disc brake, and it's going to make the center of gravity, center of mass not as easy to find as it is right now, where in this case it's obviously in the center. It kind of makes sense. So I'm going to sketch over here. When I do this sketch, I need to first project this line out. Project, I want this shape over here. Okay. And so now when there you go. Where is it? Yep, okay. 45. Once I do this, I'm going to use the revolve tool. If I press, which is down here, create revolve, I'm going to press this profile over here to revolve, and I'm going to revolve it around this axis. And if I do that, I should get a shape like this. So now this is actually looking like what a disc brake we imagine it would look like in a car. And we press OK, and now the center, let's see. I'm going to delete this one. So if I go to center of mass now and I go to inspect, center of mass, I press the body. I want, this is all, these two bodies are not joined together. So before I do that, I will go to combine this body with this body, press OK. All right, so it's all one body now, and I can go inspect, center of mass, press this. That work? Okay, so select it over here. It's all selected. I press OK, and now the center of mass is now there. So we can use it in our design. To find out where the center of a mass of an object. That would be kind of difficult to do by hand. You could do it. And this is also, I think you can compress multiple bodies in the center of mass, which is relevant if you have things of different like density. You could find that out. All right, next thing that we can use with Fusion is if I wanted to actually attach this to a wheel, I'd have to put like some nuts and bolts onto it to attach it to like a wheel frame. If you're doing it by hand drawing, you'd have to physically draw that. But we don't have to do that with Fusion. We can do them automatically. The first thing before, actually, do I even have to do that? I think I can just manually put it in. Right, okay, so you would have to draw the nut by doing a hexagon and then extruding it. But one of the advantages of CAD software, modern CAD software, is you can just insert parts directly to your design. So I can go to Insert. If I go to Insert, McMaster Car component, this is a catalog. Now, Fusion 360 is a CAD software that's designed to be used by professionals. So if you're, or people who are making products, like they want to make a product to be realized. And this catalog supplies of like, as you see here, these are basic components like washers and nuts and rivets. They upload their files on there, so it encourages you to use their components, and then you can directly buy it from here. So you could go through and use 100 of the washers and then buy it directly from a supplier, and it should fit perfectly into your design. Now in this case over here, we just want to, let's see how we use this. Now granted, it's not very useful for us because this is designed for America because this is an American number. but the actual dimensions of the products are useful. So I just pressed the nuts there. We just want a hex nut. Nothing special with this, so we'll just press hex nuts. A lot of information about this. Let's just do, I'm just going to press a standard hex nut. Over here we have our values, and these are in imperial, but I believe they should also have metric. No? Okay, so let's go back. No, let's go over here. Let's pick metric. This is the M scale, so let's say we have a M5. So we have M5 over here. M5 means the thread of that nut is 5 millimeters. So I pressed M5, picked just a standard one over here. M5, so I could buy this specialty nut, or not even a specialty nut, I could buy this from a supplier and they're going to guarantee it within a certain tolerance. There we go, package of 100 is $4. I believe it's American dollars, but still, we can encounter that in our design. But if we press this number over here, we can over here download the CAD file of it. So I believe we go to, I think it's IGES. If we click IGES and we press download, nope, step, okay. Press the step format, download. And now we have the nut in our drawing, so we can include this directly into our object. We can then rearrange it to a place that makes sense, and I could align this to, well, we will align it, but soon. So press OK, we have the nut there, and I want to align it to the hole in the wheel here. So I can also do that in my design where, capture position, where I just want to make a hole over here, and we know this has to be 5 mil. Okay. Finish. Extrude. So I want to align this up there. Now we've done the move command before in our last lesson, so let's learn something new. Let's learn the align tool. So if we look at the image of the align tool before I click the button, we see there that we have those faces and they have like a white border around it and a little square in the center. That's saying I want to align this face with this face, but also what are you going to align it with, like in the X, Y, Z coordinates. In the picture there, we want to align the center with the center. If I click it, and so we want to align this hole over here. Notice when I hover my mouse over it, it tries to predict you want this face, even though it's okay, it's not actually a face, but it's like what if there would have been a face there. That's like the center of that cylinder that we've removed, and that square component is as in like those white corners are saying this is what we want to align it with. So I press the button here. And now we want to align it with this nut over here. So if we hover over any of the circular components, we can see we can do the same thing with that nut. We can click that, and now the nut should have aligned over there. Depending on your drawing, if it's incorrect, you can flip it. So it'll be on the other side, depending on where you do your alignment. And you can also change the angle. And then if you press OK, Great, you got that nut there, and then you can do the same step we did before, where you can do a rotation, so do a rectangular pattern to make multiple copies of this nut. So another feature that TLDR of this is, as you're making a component, you can insert components from that already exist. You can also insert things from your other CAD designs. Where this becomes really well is things like bearings. Oh, there's actual whole objects in here as well. Bearings are a component that would kind of be difficult for you to make yourself, because you have like the rings and then the individual balls and then the spacings for it. Being able to just go and insert a bearing and not having to, knowing that it's a real part. Once it loads. It's taken too long, but you could put a bearing in, and you can experience those yourself. You will have an assessment task in Year 12 when you, in the public transportation unit, where you will have to make a CAD drawing of a car component, and for that task, one of the requirements is that you successfully import components and make them match with your design. Another feature we can have here is, actually I'm going to quickly copy this. So, let's go 6. So I make my 6 copies, and then let's go and pattern, circular pattern, capture position. We want to get this body, we want to rotate around this, and then if I make this 6 times, we should get. Right. So next thing that we can use, we can very easily adjust what the components look like. So this disc brake over here, if I right click this, I can change the appearance of this object. So under I right clicked that appearance, it should load up the appearance menu. Now right here, this is just steel. All right, let's say do I have magnesium? I might want to change my brakes to look like something else. Let's say, what do we have here? We don't want steel. Let's just say, I don't think you should make brakes out of stainless steel, but let's say for some reason you do. We can put stainless steel, and we can click our object, and now our thing is made as the appearance of stainless steel. It doesn't really make a difference here. Right? We see the slight color change, but when we go to our next step, we can go and render this, and as we render it, we can use those different materials to get different colors out. Local render standard. Don't worry about these render settings. We'll do more detail into this later. I'm just going to try to get a render out. I'm going to pause the video while it's rendering. Okay, so I think the rendering's done here. If I click this render over here and we open it up, we should see a shiny break, basically. Okay, it's not the best color difference, but the stainless steel is shinier than the nuts that were used for the bolts. And then you can also, in appearance, you can also change the color. If an object has paint on it, you actually want to make the appearance. I'll show you. If these nuts over here, let's say these nuts are actually painted over the top, and well, in that case, the paint. Where do we have these copies? The paint is actually made out of acrylic, is what the paint that covers cars. So when we change this appearance, we can, let's say we're going to make them red so they look like high performance racing ones. We can go to paint. We can give it metallic paint. We can give it metallic red. And then if I press this, it should, there you go. So now that those parts are red, and if I did the render, they should come out as metallic red paint. Another component we can do with this, we can inspect, which one? We can inspect what the inside of a component looks like by doing a cross-section analysis. Press inspect cross-section, I press this plane over here, and if this all works now, we can look visibly what the inside of our object looks like. So this is like our drawings, and this part over here, if we zoom in, this is actually what like the cross-sectional of the drawings should look like. Remember how we said it had those angled lines and they change based on the material? So we can use that visibly. We can rapidly change to see the different cross sections of our drawing. And this is something that you really can't do that as easy by hand. You'd have to do a whole new drawing to find that out. And then last part that I think we'll have time to do is I want to see if I can get some sort of simulation out. So if I go to simulation over here, what do I want to do? Create study. Let's go for this. For this simulation, I actually want to remove these. So hold on. Just to make it quick, I'm going to delete the nuts that we imported just for the sake of the simulation. So I want to simulate this over here. Let's see what we can do. Constraints. This thing is connected to the car by these surfaces over here. And then our loads we're going to put on this. Actually, no, not this load. I don't know what that is. We're just going to give it a structural load. Let's give it a moment. Let's say I want to move this. Yep. 100 Newton meters. In that maths question we did previously, right? It was like 200 Newton meters. I don't know. Let's just try 100 Newton meters and see what happens. So I'm putting a rotational force on the brake. And so what I'm doing here is I'm spinning the outside of the brake, and it's being constrained by these parts in the middle, which is where it's connected to the car. No contacts needed because it's all one body. If I go to analysis, if I go to solve, okay, apparently this is all good. Solve. Solve one study is going to be done by cloud. We'll see. And once this is done, I'll unpause the video. So this thing is fully received everything, so I can press OK. Did this work? I don't know. So I put a moment on here, and let's see what's happening. Factor of safety, I don't actually want factor of safety. I want stress. Shh. That's enough. So I have stress over here. If we look at the place that has the maximum stress as I put a torque, it should be this component over here. Is that like an interior component maybe? Oh, I see the issue. My design actually wasn't touching. Oh. I'll fix it. I'll actually do the tutorial again better in the future. But if this worked properly, we can actually disappear parts of the design that are low stress, and we can identify where. So over here in this part of the design over here had the most stress. So what that means, before you go, that if a crack was forming, the engineers know this is the area of the design where the cracks would form first. So we can inspect that.
Attention students, staff meetings are on today.